Page 161, number 21. Sketch a graph of the rational function. Check for intercepts, asymptotes, and holes. And our function is 3x over x squared minus x minus 2. Okay, so before we sketch a graph, let's do these other things. Check for intercepts, asymptotes, and holes. So we're going to have to find the x-intercepts first. We're also going to have to find the y-intercept. We need to find any vertical asymptotes, horizontal asymptotes, and if the graph has any holes, we need to find those as well. All of these will help us make the graph of this function. First of all, x-intercepts. Now, x-intercepts, that's where our graph goes through the x-axis. All these points are something comma 0. To find x-intercepts, we have to plug 0 in place of y. If I plug 0 in place of y, that means this whole fraction is going to equal 0. Well, the only way to make a fraction equal 0 is to make the numerator equal 0. So, to find x-intercepts, we set the numerator equal to 0 and solve for x. Well, if I divide both sides by 3, obviously we get x equals 0. Now, careful. What we really want for our x-intercept is a point. We want to say, hey, when x equals 0, that means y also equals 0. So there's our x-intercept. Okay, to find our y-intercept. To find y-intercepts, now y-intercepts are where the graph goes through the y-axis. All these points are 0 comma something. So to find y-intercepts, we want to plug 0 in place of x, see what we get for y. So if I plug 0 in place of x, I get 3 times 0, or 0, over 0 squared minus 0 minus 2, or negative 2. So the y value I get is 0, which makes sense. When x equals 0, y equals 0. So my x-intercept and y-intercept, same point, goes through the origin. Okay, vertical asymptotes. Now vertical asymptotes are really where my graph does not exist at all. Now my graph does not exist wherever that denominator is equal to 0. So what we have to do is set that denominator equal to 0 and solve for x. So to do that, we're going to have to factor this denominator. So up here, before I set it equal to 0, I'm going to try to factor this denominator. Well, to factor this, I know we're going to have x times x. And I know my next terms are going to multiply to negative 2. So I'm going to go with minus 2 and plus 1. We can test this using FOIL. That will give us x squared minus 1x minus 2, so it does indeed work. So to find my vertical asymptotes, I have to set each of those parts equal to 0 and solve for x. So x minus 2 could equal 0, or x plus 1 could equal 0. Well, this first one, if I add 2 to both sides, I get x equals 2. The second one, if I subtract 1 from both sides, I get x equals negative 1. So I've got two vertical asymptotes where x equals 2 and x equals negative 1. Okay, horizontal asymptotes. To find horizontal asymptotes, I use those rules. Well, the rules tell me that if my greatest power on top is less than my greatest power on bottom, like in this case x to the first, that's less than x to the second, then my horizontal asymptote is at the x-axis. And I can write it that way, or I can write the line y equals 0. Okay, last but not least, holes. To find holes in your graph, that's where if we were to factor the top and bottom, cancel something out, that canceled out value will give us a hole in our graph. Well, we can't cancel anything out, which means we have no holes. So I will write none. Okay, let's start working on a graph. First of all, our x-intercept and our y-intercept are the same. Our graph goes through the origin. Next, vertical asymptotes. To find vertical asymptotes, let's see here. We know they're at x equals 2 and x equals negative 1. They're really not part of our graph. They just tell us where our graph goes. So x equals 2, x equals negative 1. We've got these vertical asymptotes. And we've got a horizontal asymptote at y equals 0. Now that seems kind of strange. A lot of times people will ask, how can you have an asymptote where there is a point that exists? Well, remember, the asymptote means somewhere on the graph, our graph approaches that line but doesn't touch it. At other places on the graph, our graph could go through that asymptote. Okay, now a couple different ways we could sketch this graph. We could choose some x values, find some y values. We know that this graph is going to approach these asymptotes somewhere on here. Since we have graphing calculators, let's use them to our advantage to take a look at what this graph looks like. So I'll press my y equals key. On top, I'm going to say, I'll put this in parentheses, 3x divided by our denominator. Let's put that in parentheses as well. We'll say x squared minus x minus 2. And let's take a look at this graph. Okay, from the graph on the calculator, we can see we have our asymptotes okay. There's our sole intercept. So let's go over here and sketch this graph. Curve is this way. It approaches those asymptotes, doesn't touch them. Here it approaches these vertical asymptotes. It actually goes through this horizontal asymptote at the origin. And then we have a curve that approaches these asymptotes as well. So there's the graph of this rational function.